Okay, good morning. How are you today? Thanks for coming so early to listen to me speak, and thanks to the front-end crew for this opportunity. Let's start. This talk is called Exploring the Universal Library. My name is Szymon Kaliski, and you can find me at treesmovethemose.com and at SzymonK on Twitter. So I'll be talking today about a bunch of seemingly ephemeral things and a bit unrelated to what you might do day to day, so just bear with me. First of all, I'd like to point that most of these thoughts that I'm presenting today are actually stolen, but so are thoughts in your heads. So we steal them from people smarter than us, we steal them from books and movies. So I'd like to point out a few of my inspirations. Carsten Schmidt, who is amazing artist and coder. Devin Lulin-Vega, who is also artist and coder, but does it totally different. Marcin Ignaz, with whom I had the pleasure to work with on a few occasions, who is a great data artist. And Jorge Luis Borges, whose short story is actually inspired the title of this talk. And there are many, many others, really. So first, few words about me. I'm a freelancer, and I tend to work only on projects which really interest me, because otherwise, what's the point, really? So what I do is I'm a creative technologist / audiovisual artist, but I really hate all of those terms because I don't really feel that creative most of the time, and I really lack the integrity to be an artist. So what I do is I try to put technology in places where it usually isn't, or just have fun with things. And most of this talk is going to be about my experiences doing that, and how I'm trying to think about and frame what I do day to day. So what is Universal Library? It was a very short story, 2 pages long, by Kurt Laswitz that actually inspired Jorge Luis Borges to write his infamous Library of Babel. I'm not sure if any of you have read it, but if you haven't, just go online and find it. It's like 20 pages long. It's a story about this infinite library containing infinite number of books with all the possible permutations of letters in English alphabet, including some commas and spaces. So it poses some very interesting questions about language and about creating. First of all, is there really a point to do anything? This library contains all the possible books that would have ever been written. It contains the complete set of Shakespeare works. It also contains your life story up to this point until you die. But it also contains a book filled with letter A. And this is a really, really powerful concept. At some point, librarians who explore this library start burning books, but because the books that don't make any sense, in hopes of finding only those that actually do. But because the library is infinite, it takes a long, long time. So at some point, a language evolves, and they come to the conclusion that probably the books that they have burned might actually make sense or be really important right now. But then, again, there's an infinite number of books differing by a comma somewhere, so you shouldn't be that much worried. So language for me is really inspiring, and I'm not talking here about language as a spoken language, but not also as a language as a programming language, but language as a tool for shaping thoughts. And actually, there's this powerful hypothesis that I think was mostly disproven by now, as far as I understand, called linguistic determinism, which says that you can only think things for which you have thoughts. So basically, you live in this small bubble. You live and you also feel and think and create in this bubble of language that you possess. So it's something that I would like for you to have in the back of your minds while you listen to this. And also, there's a biblical story of Babel. And this is a story about people building a tower into the heavens. And at some point, God creates multiple languages, so people couldn't talk to each other, and they stopped building this tower. But my thinking would be, if God created more languages, we would have more tools to actually explore and be creative, so the tower would be built quicker. So I didn't really get that one. So let's start with strange languages. Language for matter. So currently, we have all these new tools that allow us to shape things inside of computer and then move them to physical space. We have 3D printing and CNC milling. And at some point, I'm pretty sure we'll be able to work with atoms. So I also think that none of us would like to work with atomic assembler. So we need more languages and ways to think about geometry and physical forms. And I'd like to show you a quick demo. This is I'm using here closure, so just bear with me. I'm using a set of libraries by Carsten Schmidt called Think, and what I'm doing is I'm building up this form that you can see on your left, and I'm doing this very declaratively. I never have to think about a single vertex where something goes. I don't need to do math to calculate how the triangle looks or how this extruded triangle looks. And I can move very, very quickly between forms and swap fluidly between 2D and 3D. And I have never need to think about the maths behind that. So I just create the pipeline for these geometries. So this is really, really interesting concept, and bear in mind, I never actually specify a triangle here. I'm just creating a flat circle and then sampling it 3 times, thus getting a triangle. And if I sample it 6 times, I get this hexagon. So this is a very interesting concept of how we can look at geometry and work with it in terms of computers. And I just wanted to shout out to Carsten Schmidt. This is something that he created using this set of libraries, and he's also amazing art installation that uses this in a gallery context. So go check out the Think thing. I've been also playing. It's not a new idea, and it's not necessarily mine, but I've been playing with growing out forms inside of computers and then bringing them to physical space. So this is something that grows kind of resembling algae growth. I'm actually, with my friend and often collaborator Marek Straszak, we printed one of them on a very small scale. So if you want to have a closer look, just find me afterwards. We actually plan on scanning 3D spaces and then growing them virtually on those spaces and then printing them back again. So even right now, we can fluidly move between physical and digital and back to physical. So we need new ways and better ways of thinking about all those things that are possible right now and even more will be possible soon. Language for data. So data is everywhere, and I'm sure most of you usually work with data as a set of tables, but you can think about almost everything as data. There are some transformations that you can do on anything to get a set of numbers and then do some processes on them and output as a set of numbers. This screen is a set of numbers. You breathing is a set of numbers, etc. So there are some really interesting things that you can get out of data if you look for it in unusual spaces. And first of all, data as code. So for me, and not only for me actually, those two are really close together, but we rarely think about our code as a data set. But there's this term coming from Lisp, which is homoiconicity, which means that you describe your data the same way as you describe your code, and the other way around. So on the top, you can see what is an S expressions, which is a way that Lisp programs describe their computation, but also describe their data. So on your left is an actual multiplication of 2 and 3, but on the right is a list containing multiplication function 2 and 3. So you can very fluidly move between those two, and this way of thinking actually forces you to look in a different way at your code. So this makes you work with things like metaprogramming really easily. But for other languages that don't possess this infinite power of Lisp, you have ASTs, and I'm not saying those things are the same because they are not, but you can always treat your code as a data set. So I've been toying a bit lately with shaders and GLSL, and there's this problem I have where I create something and I want to control one of the things from outside with a little bit of UI. Usually what you have to do is you need to go back to, first of all, you need to export a thing called uniform, which is actually a variable you can control from outside of GPU. And then you need to switch back to your JavaScript code, write your UI, connect those two together, and then you can get back into writing code. So it got really tiresome while exploring and playing with this thing. So I just wrote this really simple, like 20 line long, small library, not even, that uses AST of GLSL, analyzes it, and then grabs the uniform starting with the UI and creates appropriate UI based on type. So I can stay in my mindset of working with shaders, and the feedback loop got really shorter because I can stay and thinking about the thing that I'm working on right now. So I'm just trying to show it to you that you don't only care about those things if you write a compiler. You can get some very interesting properties out of treating your code as data in your like day-to-day even. So data as relations. There are relational databases, but I'm not going to talk about this today, and I think you see a pattern in this talk already. There are I've been really interested in exploring tree structures and graphs as a ways of doing interesting things with computer. So this is one of my old experiments where I created this small demo that allows you to draw a graph structure, but then these little green dots start going around, and when they hit the big one, they make a sound. So what you are doing, you're actually creating a composition. I'm not playing any sound because it's really awful. It was a quick hack, and I didn't pay attention to audio at this point, and never got a chance to get back and fix that. But if you go to my website, you can find it and play around with it. Interesting thing here is that it brings a bit of synesthesia into you, because you start thinking about music in a spatial sense. So that has been really a really interesting thing to do. And also, from some of the JavaScript developers, everything is held in one JSON file. So like saving the database and reading from the database was really simple. I just save connections between those guys and their positions. And then if I draw everything based on that and modify just this one element, this single atom of truth, I get things like saving really easily. And there's also one pro tip: if you do things like that and want to have a short feedback loop, try putting this thing into local storage. Then when you refresh, you're back in, so you can have like auto reload somewhere running, change your code, and it still runs as it would even with the full refresh. So moving on. This is actually from one of my first projects where I worked on interactive movie. So it's a movie that you can watch and then click through scenes. And when we started working on that with a crew of filmmakers, I really didn't want to hard code things in the front end. So I've made them this tool that allows them to just drop the scenes together and connect them. So at the beginning, we thought that we'd only have few scenes, and there's going to be like 2 alternative endings maybe. But once they started playing with this and actually thinking in terms of this tool that we created very early on, they came to the conclusion that this film could be huge. And if it's easy to work with this data set and describe those relations, you can invent. And we ended up with this whole structure. And last thing, when it comes to relations, you can also describe computation in this way. And probably some of you have heard of visual programming languages like MaxMSP or Quartz Composer. This is actually all JavaScript. It's Electron and React and Flux, all the cool stuff. This is a tool for musicians that transforms MIDI signals on the fly. And this is something I've been working for Hermod Lowy company. It's still unreleased. The idea here is that you as a musician want to do some processes on your MIDI data and probably control a few different things. It's always hard to do this if you're not a programmer. And we didn't want to go as low as MaxMSP does, where you work on very low level MIDI data. We just want some input, some processes, and then output it somewhere else. And I'm not even sure if this is a tool or a language. It's for sure not Turing complete, but I'm not sure if you even always need that. I would call this like a mini DSL or something like that. And yeah, for the JavaScript developers out there, the processing is running in separate process, a forked one. So the interesting thing here is, even if the UI lags, it doesn't hang the application and actual audio, like MIDI data processing, because if you're making music, you want this as fast as possible. So there are all these tools that we have, and you can use them in interesting ways, doing things like that. Language for art. And don't get me wrong, I'm not talking here about the whole universe, about amazing artists doing deep and powerful works with computers. This is an art with small a, and it's basically about things that I've been doing that are pretty much unnecessary and unneeded by anyone. It's just having fun. So for me, if you work with art in terms of computation, you really need to choose some kind of fabric, something you work with. And interaction is an obvious one and a simple one. but also one that's interesting to explore. So I worked with my friend Marek Straszak, creating this installation where you have this set of deconstructed steel platonic solids with some Arduinos put on top that are connected to computer via Bluetooth, and they have this small solenoids, which are electromagnets hitting the thing. So because all of those forms look different, they make different sound when you hit them. And I've made this simple touchscreen-based interface where you can sequence the ticks. So thus, like creating some kind of like music in a gallery context, which has been really interesting because I'm pretty sure all of the people that play with that during few festivals where we had that have a computer at home, but I'm also pretty sure only a small percentage of them actually downloaded some kind of music making application and started playing at home. But here in a gallery context, they did. So that has been really interesting to see. But there's also interaction data that you can get from very, very strange places. And this is, I helped my friend Rafał Zapała with his project Sensorium, where he created musical score based on your emotions. So we are using, there are consumer-based EEG sensors that you put in your head that you can see on the top image, and we're also using pulse sensor and galvanic skin response to get your emotions out of your body, transform them in a set of numbers, and then based on the numbers, we can change how the score develops. So basically what is here is a huge biofeedback machine where you sit in this comfortable chair, listen to the music, and then the music changes based on how you feel about it. So it's a bit hand-wavy, I know. I'm just showing this because there are things you can do with programming that go outside of web browser. And there has been actually some JavaScript in that project, so it's not totally irrelevant. But you can also use data as fabric. And there's even a term for that called data art, which is actually data visualization that you can get nothing out of. So I had the pleasure to work with Marcin Ignatz under his variable.io company and with Henryk Wolik to create this data art for last year Google I/O, where we basically showed all the Android users on this huge 27K screen. It was all done in JavaScript and WebGL, and at some point was running in Chrome with only like small percentage of that asset, but near real time. This thing was actually a big set of PNGs. But interesting thing here is to work with data in that way, you need to first to explore it. And there are no tools, and I'm pretty much sure there will never be, that actually hit the specific thing you want to do. So you need to build tools to shape your mindset to work with some things. This is one we've built to actually explore where the places are over the earth and how we can show them and how many people are where using Android devices. And there are some screens of pretty pictures that never made it to the final version. So I really wanted to show that to Marcin Ignatz and his PEGS library. If you are bored with Free.js and do WebGL, check it out. Yeah, algorithm as fabric. And I don't really have that much time to explore this, but lately with things like deep dream and deep neural networks, but even taking a step back and doing procedural and generative art, it poses some interesting questions. Like, if you're building, artists are basically changed from doing the thing to being curators. So they create an algorithm, a set of rules, or they even learn something to create art, and then they choose the output they like. So at some point, I'm pretty sure we'll be able to actually create artists that way. So the neural network will become this artist, and people might start buying artists instead of buying art. And I'm not really sure if this is ethical, or if you can say you created this. Are you a god then? If you want to talk about it, just find me afterwards. Last thing, language for tools. There's this powerful quote by Marshall McLuhan, who is a media theorist, who said that first we shape our tools, and then they shape us. And I have a little backstory to all of that. When I started doing freelance work around 3 years ago, I made my own time tracking tool because it served a few purposes. First of all, I wasn't really sure how to price myself. So my idea was to track how many hours I spent on projects and how much I earned. And then based on which ones I liked, I will basically know where my price point is at this point. But also, I was really interested in how much time I work and on what. So over time, the focal point of this tool became this big table sorted by how much money I make per hour and on which projects. And at some point in last year, I actually stopped doing any personal projects. And don't get me wrong, I knew they were there. I wanted to do them, but subconsciously, they gave me no value. So I ended up in a little bit of a bad place, and it was really, really strange feeling to have when I realized it. And I realized it because Devin Vega talk called, I forgot the name, but I will tweet it later, where he describes his own time tracking tool and how he looks at things. So right now I'm trying to be more conscious about this, and there's this question if at some point the machine is working for you or you are working for it. And I really understood that at that point I was working for the machine, not the other way around. So I started working on a new version of that. And I know this database is really ugly, but it doesn't need to be pretty. It's not for a client. It's only for me, and it needs to send me a message. So this is all the ticks. The ticks here are by week, so you can see this whole big place where I stopped doing any personal work. And this, for me, is really important. And I started the big peak at the beginning of 2016 is where I actually started working on this new version. But then I also work a lot, and I've been working more and more over the years, so I'm not really sure if any of that is working. But at least I got time to, I forced myself to find time to work on things I'm passionate about besides client projects. But the most important part of this tool that I'm trying to force myself to look at daily is this visualization of all the days during a year. So there are 365 or 66, depending on the leap year, gray squares for each of the year. And it's colored in red if I worked on client project there. It's colored in blue if I did any personal work then. And in both, obviously, if I spent time doing this and that. So you can see in 2000, this is from a few days back. In 2016, I already spent more days working on personal things than in last year. So it's a big win for me, and I'm happy that I can actually not even force myself, but shape my thinking using this tool. And there's also another interesting thing with this. I have these years going back 50 years into the future. So this is as much as I could hope to get. So it really forces me to put the things I'm doing in perspective and see the time passing as well. And this is really a really powerful concept. And yeah, so getting close to the end, we have language, we have tools, and we have thinking and making. And they are all connected in this very strange ways of feedback loops where you make tools and think and make with your language, but then tools influence your language, and the same with thinking and making. It's all connected, and it's really hard to be conscious about these things, but you really need to, because you can end up in a place you wouldn't suspect if you don't do that. But also, on the other hand, there's this term that I also stolen from Carsten Schmidt of current Cambrian explosion of languages. And I think this is extremely good thing, because you can only find some meta patterns, some big ideas if you look at the spectrum. You can't look just at one thing and expect to be creative and build new things and amazing things if you don't know what's out there. So I would advise you to play around and just spend a weekend with Clojure, try Haskell, try Brainfuck, try whatever. Just go outside of your normal thing you do day to day, because it can really bring some ideas outside. For me, and most people tell that, learning Lisp actually changed how I think about programming with all the other languages. But I'm not saying just go to Lisp. I do JavaScript mostly day to day. I'm just saying try those things and learn from them. So yeah, thanks, and if you have any questions, just come find me afterwards.